Hey guys, in this lesson we're looking at doing an introduction to proofs. And proofs are a way to take all of the things that we've learned so far and pull them all together in one type of a problem. But before we get too much into that, when we're looking at a proof, basic definition, it's a math problem that has the math rule. And when we're talking about a math rule, that can be a theorem, a postulate, and or a definition for each step, and the steps are called statements. And a proof is not going to be complete without the reasons to justify each step. So a math problem that has a math rule for each step. There's lots and lots of different type of proofs that you can write. The one that we're going to be doing in this class is called a two-column proof. And it's called two columns because whenever you see it written out, it's going to have two columns in it. One column is going to be called statements, and the other is going to be called reasons. So statements is where all of the math is going to happen. And that's what you are going to be most familiar with, is the statements portion. The new part that we're adding is the reasons part, and it's basically taking all the math that you usually do and just saying, well, I know this works for sure in math because of this rule. So the way you know where to start with a proof is that you're going to have a given. A given is what you're given to start with. It's the starting point or the problem that needs to be solved. And sometimes they'll put the given in an if-then statement, and the given is always the part after the if. So the next one we're looking at is prove. Prove is the answer that you're given for the problem that you're solving. And it's where you're trying to get to from the given. So basically, this is your start. This is your end. Okay? And with proofs, they will be found, if you're given an if-then statement, they will be found after the then. So we can use all the math rules that we've been given so far, but there's some that I want to talk about because it's probably been a little while since you've seen them, and there'll be one or two that'll be new that I'll show you. The first one that they could use is called the reflexive property, and it's given any value for A, you can do A is equal to A. So basically, same thing equal to same thing. And it can be equal to or congruent, same thing. So if we look like what that looks like for algebra, we've got 3 is equal to 3. That's a true statement. If you've got 3 on one side, you have to have 3 on another. What that's going to look like for geometry is you're going to have AB, and you're going to say, well, that's also equal to AB. You can also do it for angles. Angle ACB is going to be equal to, and it can also be congruent because it's equal and congruent. It has to be ACB in that exact order. So same exact thing equal to same exact thing. So they use this a lot to introduce new things. That aren't mentioned. Anywhere in the proof. And it usually comes from the picture. And it can be either a picture you draw based on the given information, based on what you know for sure is going on, or it can be a picture that they give you in the problem. Next one we're looking at is the symmetric property. When you're looking at the symmetric property, if you're given any value of A and B, if you've got A is equal to B, then you can write B is equal to A. And you see this a lot in algebra. You'll have some algebra teachers where if you see this, they'll be like, that's not done. You've got to have the X on the left side. So they would want you to write X is equal to 3. And the reason why this works is because of the symmetric property. So what that would look like for geometry, if we were talking segments, AB is equal to 3. You could also have, and then you would be able to write it as 3 is equal to AB. You could also have AB is equal to CD, and then you could rewrite that as CD is equal to AB. You could do the same thing for angles. Angle A is equal to angle B, and you could rewrite it as angle B is equal to angle A. With the transitive property, given any three values, if the first one is equal to the second one, and the second one is equal to the third one, then the first one is equal to the third one. So what that looks like geometry-wise, if you have AB is equal to, and this works for congruent as well. So we can do transitive as equal or congruence. We can do symmetric as equal or congruence. So if we've got AB is equal to CD, and if we also have CD is equal to EF. So if we have both of those things, then we're able to say that AB is equal to EF. Because if AB is equal to C, D, and CD is equal to EF, since those are the same exact thing and they're equal to each other, you can say those two are equal to each other. Next one is the substitution property, and that's just putting in any value or expression for another value. And you guys have done a lot of this. Anytime you're given something like 2x plus 3 and you're told that x is equal to 7, when you take that 7 and you put it in for x to simplify it, and you do 2 times 7 plus 3, the reason, so this would be your statement, the reason for that step would be the substitution property. So in terms of geometry, if we look at it, it would be like if we had angle ABC is congruent or equal to angle DEF, and we know that angle ABC is also congruent to angle LMN. I could take this ABC right here, and instead of that ABC, I could write DEF because those are the same value. So instead of an ABC, I'm going to write DEF is going to be congruent to angle LMN. So you notice how I took this statement right here, and the only thing I changed was I kept the LMN, and I changed the angle ABC to a DEF because I knew they were congruent. That's your substitution property. So basically, anytime you're looking at something, one step, and you say, well, instead of this, I wrote that because they're equal values, that's substitution. And substitution works for both equals and congruence. But again, the big thing is instead of blank, I usually say this. You write blank. I usually call it that because they are equal. Or congruent. substitution property. This one is used a bunch. The next one is algebra, and it's a reason used in a proof, and it's when the same value is added, subtracted, multiplied, or divided on both sides of an equation. You do this a lot. Anytime that you are solving an equation, you're using another way you'll see it. These usually called, you'll usually see them, and they're listed on the next page. The addition property of equality. Anytime you're using those, or anytime you're solving an equation, you're using these properties. It's just something that your math teachers in elementary and middle school kind of glazed over. They told you about them, but then they didn't ever talk about them again because you knew how to do it. But the reason why you're able to add the same thing to both sides and it works is because of the addition property of equality. And it's the same for the other operations as well as the distributive property, and that all follows under algebra. So what that looks like, it's like when we've got 2x plus 3 is equal to 7x plus 4. And the first thing you're going to say to do is, well, you're going to subtract the 2x from both sides. Anytime you're saying subtract, or do whatever operation for both sides, that's going to be algebra. With the exercises that we have, they just generalize and they say algebra. There are other proofs and exercises that you could do where they're going to want you to be very specific and say exactly which operation that you're doing. So anytime you use algebra as a reason, make sure you're also thinking this is algebra because, and like this example, I am subtracting 2x from both sides, and that way you're remembering that it's the subtraction property of equality. So the next step would be 3 is equal to 5x plus 4, and you would say the reason that you went from there to there is going to be the subtraction property of equality, or for the exercises we'll do, algebra. And what that'll look like in terms of geometry, let's say you've got AB plus CD is equal to EF plus AB. And we're trying to get to CD is just equal to EF. And that's our proof, and that's where we want to go. So if we look at this step right here, the reason why we're not there yet is because of the AB on both sides. But if we subtract the AB from both sides, that'll just leave us with the CD is equal to EF. The reason for this step would be algebra, or the subtraction property of equality. And these properties that we use for the add, subtract, multiply, and divide only work whenever you've got an equal sign.